All right, guys, welcome to chapter 14. This chapter is all about advanced scripting. So, we've built a solid foundation in scripting throughout this class, from command line basics to microelectronics. Now it's time for us to take it to the next level. This chapter is all about advanced scripting techniques, and we're going to explore different powerful ways to work with PowerShell and Python to build more robust, efficient, and resilient automation solutions. So, building on what we've learned, this chapter is designed to expand our automation abilities, right? We're going to move beyond simple commands and look more at sophisticated techniques. We're going to focus on some of those advanced methods in PowerShell and Python that are absolutely essential for any professional who needs to build powerful and reliable automation scripts for production. So let's start with PowerShell. A key concept in PowerShell is that the commands are output as structured objects, not just plain text. Often a command gives us a big collection of objects, but we only need a few of them. So the where object commandlet is where we're going to use our tool for filtering. The magic here is going to be a special variable. The special variable is going to be $_. Now this is going to represent the current object coming through the pipeline. In this example, we're going to get all of the services on a system and then filter them down by only the ones whose status is stopped. Once you have the objects you want, you don't need to see all of their properties. So the select object commandlet allows us to pick exactly which properties we want to display. Here we're going to get all the processes, but we only want to see the name, the process ID, and the CPU usage for each one. You can also use the select object to grab a specific number of items, like maybe the top 5 of a sorted list. Now, this is really a powerful feature of select object. You can actually create new properties on the fly by using a special hash table syntax. This is perfect for converting maybe some of that data or doing simple calculations right in your command. In this example, we're selecting the file's name and then creating a new property that we're naming size in megabytes. The expression for this property takes the file length in bytes and divide it by 1 megabytes. Now this is going to give us a clean, easy to read megabyte format, so that way we don't have to read everything in bytes. We can continue defining down through here and actually use something called built-in remoting. Now this command through PowerShell allows us to run commands and entire scripts on remote Windows computers just as easily if we were on the local machine. This is definitely a game changer, and you will be using this quite often when you're in an enterprise environment, especially when you need to run the same command or the same script on 3,000 different PCs. Now there are two main ways of using PowerShell Remote. The first one is enter-ps session, which is a fully interactive session on the remote machine. Your command prompt will change to show you that you're connected, and then from that point on, every command you type is going to be on that remote machine. The second command could be invoke command, which is non-interactive. It takes a blocks of commands, runs them on one or more remote computers, and then just returns us the results of it on our local machine. This is what we're probably going to use 9 times out of 10 when we're dealing with thousands of machines. Ideal for scripting and automating those tasks when we're dealing with many servers all at once. Now in Python, we're going to use what's called the OS module. When your Python scripts need to interact with your operating system, like managing files or directories, the built-in OS module is our go-to tool. It's going to provide us a portable way to perform common operation system tasks. Now, this is one of the most important functions in the OS module, the os.path.join, because different operating systems use different characters to separate out directories in a file path. For instance, Windows likes to use a backslash, while Mac and Linux uses a forward slash. If you build a path just by adding strings together, your script will break if you change the operating system. Now, if we use that os.path.join, this is going to be solved automatically by using the correct separator for whatever system that we're running on. Now, you should always build the paths in your scripts for the OS that you're working with, but remember that we're building the path as a absolute path and not a relative path. The OS module, on the other hand, is got a ton of other tools, okay? Now, some of these other tools could be like the OS make dirs. This will create a directory and smart enough to know, well, is there any parent directories along the way and know what operating system that we're working on. The os.path.exists is a simple way to check to see if a file or a directory exists before we try to use it. It will return true if the path exists. The os.remove is a great way to delete a file. Again, we're not using the OS commands directly. Instead, we're letting Python determine what operating system it's running on and run the proper commands needed to complete these tasks. Now, there's another advanced process called the subprocess module. It's very common for a Python script to need to run external command line programs or even other scripts. So the subprocess module is the modern standard way to do this. It's going to allow our Python script to run any other command that we could do on the terminal. So if we use that subprocess, there is another function called .run. And this is the recommended way of running these commands. You pass it the command along with a list of strings. The first item is the command, and the following items are its arguments. The two most important parameters here are going to be the capture output equal true, which this is going to tell us to save the command's output instead of just printing it to the screen, and the text equal true, which decodes that the output is a regular Python string. So it's a great way for us to capture what the command did and then use it in a variable, such as result, as we see on the screen, to process it. So the run command returns a special completed process object, which is going to give us everything we need to know about the command that we just ran. There's going to be the result.standardout, which contains the standard output. We're going to have result.standarderror, which contains any error messages, and we're going to have the result.return code. Now, this is going to give us the exit code. Remember, on most operating systems, 0 typically means success. This way, we can catch that if any errors do occur, that we can catch them and complete other code in case of exceptions. Now, we've done the request library a couple times, but requests actually have a ton more features built into it that we need to get used to using. Because when it comes to interacting with websites and APIs, this is going to be the standard library that we're going to use. It's a third-party library that you have to install with pip, but it makes the process of making HTTP requests very simple and more intuitive than any other Python built-in requirements. Using the request library is pretty straightforward. After you import it, you can make a GET request by doing request.get. Make sure you put in the URL that you're trying to get. Now it's going to handle all the complex details for you. Just like we did with uRequest on the microcontroller, the response object it returns is going to easily give us a status code, the content, and a JSON method, typically parsing the JSON format. And remember, 200 means success in this case because we're using HTTP codes and not operating system codes. As our scripts get more complex, though, we're going to need to catch errors. We're going to encounter these errors. Now, a network might be down, a file may not exist, or even a command might just fail. So, without proper error handling, these issues are going to cause our scripts to crash. So, we're going to use things called structured error handling. And this is a technique that we're going to use to anticipate these problems and manage them gracefully. In Python, it's pretty straightforward. We're going to do the try except block. Okay, you're going to place your risky code, the code that might fail, inside of a try block. If an error or an exception occurs, the code in the except block will be executed. Now, the program's going to continue running instead of crashing, which is why we like to use the try except blocks. And then we can also use what's called a finally block, which contains any cleanup code that will always run whether or not there's an error or not. This is a great way to turn on or off your Wi-Fi connections, close connections, or even clean up any files that need to be cleaned up after a process is completed. In PowerShell, we're going to use what we call a try-catch. It's a very similar structure. So you're going to put your risky code in the try block, and if it has an error, the script immediately will jump through to the catch block. Now the catch is going to handle it and run some different code. The main difference in PowerShell is it considers an error it only runs if an error is worth catching. So for example, you can catch certain types of errors, maybe network errors, maybe syntax errors. You don't have to catch every error there is. So the concept for this is going to be the PowerShell error handling of the error action and what you want it to do. By default, many commandlets will produce a non-terminating error. Now you'll read the red text to the console, but the script will continue running. A try-catch block will ignore these by default, and so to make these errors catchable, you need to add the common parameter of error action and what you want it to do. For instance, if you do not want the script to continue, we will tell it to stop. Or maybe we'll tell it to pause. Or maybe we'll tell it to continue, such as, I don't care if this error occurs, just continue running. All right, to wrap up, we've learned a few different powerful commands, advanced techniques, building automation scripts, which we'll do in a couple of the chapter projects that we do in chapters like 18 and 19. Just to let you know that we can use different things like Python libraries, interactive file system, and external systems, and most importantly, we now know what error handling is. Now, you may not know exactly how to implement it properly, but that's going to take some muscle memory. Just know that we use the try except finally and the try catch in Python to be able to make resilient and reliable scripts. I'll see you next chapter for chapter 15, which is the final chapter of the main content of the book.